This is the second video of genetic algorithm in continuation with the first video. In first video, I have complete the topics of introduction to problem solving and genetic algorithm, optimization methods, basic concept of genetic algorithm, biological background, the working principle of GA. Right? These topics are covered in first video. Now in this video I will discuss about the important topic of GA operators and one sample example how GA programming run. Let's start. This flowchart shows how genetic programming is done. So the first step is to set a population, assign a fitness, then select two parent, then the processes followed are crossover, mutation. Okay, after these two processes we get fittest result out of all, and if the result is optimum then the program get terminate, and if not then it will start from selecting the individual parent. So the methods involved or the steps are selecting population, assign fitness, select parent to individual, use crossover operator, score them, use a mutation operator, score them, and apply a replacement operator to incorporate individual into population. Okay, so this flowchart is very important to know or to write about genetic programming. Now for these process, the different steps assigned to the program are encoding. So before applying genetic algorithm to solve any problem, a method is needed to encode potential solution to that problem so that computer can process. So encoding is the input for the program in computer. Right, we cannot use directly the problem, say fx is equal to x square. So we have to give coding to this to run a program. So one common approach is to encode solution as a binary. So we have to convert the problem into binary coding, and binary means sequence of ones and zero, where digit at each position represent the value of some aspect of the solution. The problem is converted into binary digit. So there are many methods of encoding. First is binary encoding. First is binary encoding. In genetic algorithm, it was first used because it's relatively simple. In binary encoding, every chromosomes is a string of bytes 0 and 1. So say chromosome 1. So this is binary encoding for chromosome 1 and for 2. Binary encoding gives many possible chromosomes even with a small number of possible settings. This encoding is often not natural for many problems, and sometimes correction must be made after crossover or mutation. Right? This is one example how binary encoding is done. So one variable function say 0 to 15 numbers, right? A function having 0 to 15 number numeric value. So we cannot use directly this numerical value into a program, GA program. So we represent each value by 4-byte binary string. This table shows that numerical value 0 having 4-bit string, binary string represented by 4 times 0, 1 000 1, 2 number represented as a binary encoding that 0010, and so on. And similarly, say 15 number is represented as encoded number as 4 times 1, right? This is I think clear that how the encoding is done. Now, second encoding method is value encoding. The value encoding can be used in problems where values such as real number are used. So instead of binary means 0 and 1s, numbers are used. Use of binary encoding for this type of problem would be difficult, right? In value encoding, every chromosome is a sequence of some value. The values can be anything connected to the problem, such as real number or characters or objects. Say, for example, chromosome A. The values are represented, the problems are encoded in terms of values, say 1.2324, 5.3243, like that. Chromosome B can be represented as a character, say value ABDZ, EIFJ, like that. Value encoding. Permutation encoding. Permutation encoding can be used in ordering problems such as traveling salesman problem or task uh, ordering problems. So depend on problems, encoding methods, suitable encoding methods are selected, right? Simple mathematical problem can be encoded as binary. Real life problem can be encoded as a value or permutation. In permutation encoding, every chromosome is a string of number that are that represent a position in a sequence. Say chromosome A, permutation encoding as a number, say 153264798, like that. Permutation encoding is useful for ordering problems. For some problems, crossover and mutation correction must be made to leave the chromosomes consistent. Tree encoding. For genetic programming in tree encoding, every chromosome is a tree of some objects, such as functions or commands in programming language. Tree encoding is useful for evolving programs or any other structures that can be encoded in trees. Right? Means one value is interconnected with two or more value, right? Say chromosome A, as a tree encoding method, sign used are plus X, L, 5, Y. Then chromosome B, do until, step, well, like this. Interconnected values are there, then tree encoding is done. So for genetic programming, the first step is encoding. Now, this is the important topic, operators used for programming, GA programming. The operators are reproduction, or we can say selection operation. Second operator is crossover or recombination, and third operator is mutation. Genetic operators used in genetic algorithm maintain genetic diversity. Genetic diversity or variation is a necessity for the process to evolution. One important parameter is population size. Population size says how many chromosomes are in population, right? The number is very important. So before starting this operators, population size is decided. Let's see one by one. Reproduction or selection operator. Reproduction is the first operator applied on population. The chromosomes are selected to be parent, to cross over and produce offspring. So selection operator, in selection operator, the out of number of chromosomes, few chromosomes are selected to be parent. Okay, so this is the selection point. that which chromosomes are selected for further calculation, right? The reproduction operator are also called selection operators. Selection means extract a subset of genes from an existing population based on quality. So one can derive from the genes a kind of quality measurement called fitness function, right? So it is number of options out of number of options of genes or chromosomes based on their quality. Pick any two to become a parent, and further process is applied on them, only them selected chromosomes, right? And the quality measurement is called fitness function. Okay, the various method of selecting chromosomes are roulette selection, Boltzmann selection, tournament selection, rank selection, steady state selection. These are the methods. Depend on the problems. Different methods are suitable for different problems. For example, say we have one function which is maximization function fx is equal to x square. This is our problem, in which x having value from 0 to 31, right? So x value is equal to 0, 1, 2, 3 up to 31. The first step is encoding. See, if we are using binary encoding, binary representation, let's select that 5 bytes binary encoding to represent the values 0 to 31. Second, population size. Assume that the population size is 4. I have highlighted the values with red color. We show the important selection point, right? So we have selected binary encoding with 5 bytes and population size 4. Then generate initial population at random selection. They are chromosomes. Now select chromosomes for which value? 0 to 31. So say 0 like that, the encoding are like this. For example, 01101, because we have 5 bytes tree. 11100, 4 population size. So for 4 population we generate or initial population, randomly select the initial population like this. Okay, then calculate the fitness selection. Calculate the fitness, then decode. Fitness selection, after fitness, assign a fitness, then decode. Decoding shows that the binary encode 0110 represent value 13, 11000 represent value 24, 8 and 19, so on. Then evaluate the fitness. Then according to this function fx is equal to x square. So if x is equal to 13, then the value of fx is 169. Then the value is 24. The fx value is 576. Then for 8 it is 64 and 19 361. Now select parent. Now two individual. Now select two individual for crossover based on their fitness. Out of many methods for selecting the best chromosome, if roulette wheel selection is used, then the probability of ith string in the population is. Now this is the first operator is applied to this problem, fx is equal to x square, right? And the method is roulette wheel selection. The population is equal to pi is equal to, so this is the equation for roulette wheel. Pi is equal to fi divided by sigma fi. What is fi? Fitness of string I. Pi is the probability of string I. N is the number of individual. Individual is equal to number of population, and we have population size 4 over here. So n into pi is expected outcome. Okay, So we have 4 string. Okay, for them we have binary encoding like this, and that encoding represent the value of x as 13, 24, 8 and 19. Put this value into fx is equal to x square. So we get the value of fx is equal to 169, 576, 64 and 361. Now pi. Okay, pi is the probability. So probability according to this equation, pi is equal to fi divided by fi is this. And what is expected count? N into pi. N is equal to population size 4 multiplied by pi, we get the expected count. So if we do sum of that function fi and all the value pi and n into pi, we get the maximum value like this. So out of these results, what we have seen? Our function fx is maximization function. So for which value of x we get maximum value of fx? For 24 means which string? String 2. So we get the result that the string 2 has maximum chance to select. This is selection procedure according to Rowland selection. I hope it is clear. So we have selected that string to get the maximum result. So our string 2 is now select for further calculation. So our next operator is crossover. Crossover is a genetic operator that combines two chromosomes to produce a new chromosomes. One sentence. So crossover is the process of selection of parent to form offsprings. Crossover occurs during evolution according to a user definable crossover probability. Crossover select genes from parent chromosomes and create a new offsprings. Types of crossover, again the methods or the operators are 1 point, 2 point, uniform, arithmetic and heuristic crossovers. The operator are selected based on the way the chromosomes are encoding. So if we have options of encoding like whether it is binary or value or permutation or tree. Based on the crossover operator may be 1 point, 2 point, uniform, arithmetic or heuristic. So based on encoding, the crossover operators are selected. So what is crossover process? Crossover means selection of parent to produced offspring. Let's see 1 point. Say one method I will explain you. 1 point crossover. It randomly selects one crossover point and then copy everything before this point from the first parent and then everything after the crossover point copy from the second parent. Say consider two parents selected for crossover. Parent 1 being binary string 11011 then and parent 2 having this string. Now this vertical line, the red color vertical line is the crossover point, and before this line the value 11011 is from first parent and the remaining value after this vertical line are selected from second parent. Okay. Interchanging the parent's chromosomes after the crossover point. After the crossover point, interchange the parent chromosomes. We get the offspring. The offspring produced are, so before this vertical line, the values are same. Means from the parent 1, the generated or the produced offspring 1 is 11011. And after that line, the values are changed. Similarly, from parent 2, the offspring produced is offspring 2. The before line the values are same 11011. After the line it is changed. Okay. So crossover, calculate the offspring. Now third operator is mutation. What is mutation? Mutation is a genetic operator used to maintain genetic diversity from one generation of a population of chromosome to the next. It generate or maintain genetic diversity from population to next population. It maintains genetic diversity for the process. Mutation occurs during evolution according to a user definable mutation probability. Usually the value is 0.01, lowest value is set. Mutation alters one or more genes value in a chromosome from its initial state. It alters one or more value. This can result in entirely new genes and produce some entirely new genes. With the new genes value, the genetic algorithm may be able to arrive at better solution than was previously possible. So it is check that if I am changing the one binary point, then what will be the result? It may happen that the result is better than the previous one, right? Okay. Mutation is an important part of the genetic search, help to prevent the population from stagnating at any local optima. So we cannot it provide large boundary for the calculation, right? It cannot stick to a local optimum point. Mutation is intended to prevent the search falling into a local optima of the state space. The type of mutation the operators are flip bit, boundary, non-uniform, uniform, and Bayesian. The operators are selected based on the way chromosomes are encoded. So based on encoding methods, the different operators methods are used. Let's see one flip bit mutation. The mutation operator simply inverts the value of the chosen genes. Simply invert the value, like 0 goes to 1, 1 goes to 0, randomly, not all. This mutation operator can only be used for binary genes. Binary encoding method use flip bit mutation operator like this. Consider two original offspring selected for mutation. So we have in crossover operator we produced two offspring, right? For them we apply flip bit mutation which uh, invert 0 to 1 and 1 to 0. So after muted offspring, so previous offspring is after is result after crossover operation, and the second offspring is produced after mutation operator. So we have written over here that muted offspring 1 is the fourth bit. 1 is now inverted to 0 in first offspring. In second offspring, the seventh and the second last 0 and 1 is inverted, right? Fine. So this is the end of our genetic algorithms operators topic. Here we will end with one small example of maximization function fx is equal to x square, which is solved by genetic algorithm approach. Let's see. So our problem or the example is maximize the function fx is equal to x square. Devise a mean to represent solution to the problem. Assume we represent x with 5-digit unsigned binary integers. Devise a heuristic for evaluating the fitness of any particular solution. The function fx is simple, so it is easy to use the fx value itself to rate the fitness to the solution, right? So first step is coding. So we are using binary coding, right? See, GA often process binary representation of solution because this work well because crossover and mutation can be clearly defined for binary solution, right? So we have already discussed the same problem while we are explaining the theory of the genetic operators, right? So in this example we have already selected that we binary encoding with string length 5 and x value is 0 to 31, okay, and the population size is 4, right? So randomly generate a set of solution like this for with 5 string, population size is 4. So our binary encoding population is 01101, 11000, 10000, 10011. These are the chromosomes. This is called chromosome or genotypes, right? Now assign a fitness. For that, evaluate the fitness of each member of the population or the chromosomes, right? So for that, decoding is done. Means the binary encoding represent which value, which give you which we get from decoding. So the string 01101 represent the value 13. 11000 represent value 24, 01000 represent value 8, and 10011 represent value 19. Evaluate the fitness. Now assign a fitness. How? Fitness matlab which value of x give you fx maximum, right? So for 13, put x is equal to 13, we get fx value 169. If x is equal to 24, we get fx value 576. X is equal to 8, 64. When x is equal to 19, fx is equal to 361. Now, expected count. Expected count is equal to n into probability I, where n is the population size. We have selected, assume the population size n is equal to 4. Thus, the evaluation of the initial population summarized in the table below. So for we have already see the table in our previous discussion. So we have selected 4 strings. Binary encoding of this is this. Now after decoding, the values of x is equal to this. For that, fx value is equal to this, and for probability and pi and multiply by n, we get the last column. Thus from this the fx value is 576 is maximum for string number 2. The string number 2 has maximum chance to select. Now produce a new generation of solution by picking from the existing pool of solution with a preference for solution which are better suited than other. Now by generating 4 uniform 0 to 1 random values and seeing which bin they fall into, we pick the 4 strings that will form the basis for the next generation. So random number fall into bin this, and the chosen string is this, right? Now randomly pair the numbers of the new generation. Random number generator decide for us to match the first 2 string together and the second 2 together. Within each pair, swap part of the member solution to create offspring. Now our next process or step is to select offspring, right? For the first pair of string 01101 and 11000 is our offspring. We randomly select the crossover point to be after fourth digit, right? Crossover point after fourth digit. So crossing these two string at point yield these value. For second pair of string, these two, we randomly select the crossover point to be after second digit. So after second digit, we select the crossover point. Okay. Randomly mute, now this is mutation process. Randomly mute a very small fraction of genes in the population. With a typical mutation probability of per bit, it happens that none of the bit in our population are muted. Go back and re-evaluate fitness of the population. Now again assign fitness new generation. This would be the first step in generating a new generation of solution. However, it is also useful in solving the way that a single iteration of the genetic algorithm has improved this sample, right? If we cannot mute this, then start the problem from the first step, fitness, assign fitness. Okay. So this is our string initial population x value fitness. Now this is for new generation, new fitness assigned to the problem, and for this again we get the second string value is maximum. Here the second string x value is 25 and previously generated population the second string value is 24, for that x value is 576, and for this 25 we get the value of 625. Let's see, the total fitness has gone from 1170 to 1754. The algorithm has already come up with this string 11011, x is equal to 27 as a possible solution. So this is how the problem, one simple problem, can be solved in genetic algorithm. Thank you.